As the cost of renewable energy decreases and more people desire green energy, more homes are adding sources of renewable energy generation. It sounds good, right? Save money on electricity bills and generate green energy? Well, mostly. Let's talk about net zero homes and the difficulties with distributed renewable power generation. Net zero homes aim to be as energy efficient as possible and generate as much energy as it consumes over a year. However, the total generation and consumption do not occur at the same time, so it is better to connect to the grid. This way, the home can sell back electricity when generation exceeds use. The concepts discussed here don't just apply to net zero homes, but to any home with renewable generation. In fact, most homes with energy generation are not net zero. Of the 7,700 registered zero-energy family units in the US, only 1/3 produce 100% or more of their annual electric demand. Now, what about this renewable energy generation? Distributed energy generation refers to generating energy where it is used on a small scale rather than in a central location. The most common form of distributed generation is photovoltaic solar energy, although thermal solar energy and wind energy are also used. Since solar PV is by far the largest source of distributed energy generation, we will be ignoring the effects of other distributed generation on the grid. What is the grid? The grid is the system of power plants, consumers, and transmission lines that make up the generation, transportation, and use of electricity. Grids are managed to ensure the supply of energy always matches the demand. If they do not match, blackouts can occur. Since demand changes constantly, this is not a simple task and requires careful coordination with electricity suppliers. The suppliers that generate electricity charge a certain rate, which determines how much we pay for electricity. What affects this cost? At a very simple level, the cost of electricity can be thought of as the total annual expenses to run a power plant, divided by the energy the plant produces. This gives us an LCOE, or levelized cost of electricity. So, how exactly does renewable energy affect the grid? For a typical home on a weekday, power usage looks roughly like this. Usage grows in the morning, drops off when people head to work or school, and finally spikes again when everyone comes home in the evening. When you add solar generation to a house, a slight issue presents itself. Solar generation is low in the morning, peaks at roughly midday, and drops off towards the evening. This means that you don't have solar generation during peak loads. This chart shows the net load on BC on a typical summer day, if every detached home had a 2.5, 5, or 10 kilowatt solar generation system. The net load actually goes below zero for the 10 kilowatt system, so more energy is produced than the province uses. This overgeneration is not the only problem. Once solar generation decreases in the evening, power supply must rapidly ramp up to meet demand. This places stress on existing generators. Solar can have a financial effect on the grid as well. Let's look at the LCOE for an imaginary power company that built a gas power plant to provide electricity to a grid. The LCOE depends on the annual cost to operate the plant and the power generated. If the homes add solar generation, the power plant supplies less electricity during the day, but peak loads in the evening are only affected slightly. The plant may save some operating costs, but the cost to own the plant has not changed because it still needs to meet the peak demand. However, the power plant now provides less power overall, so the LCOE increases. In some states, such as California and Hawaii with high solar penetration rates, the price of electricity could increase by up to 20%. Predictions show that residential solar generation in the US will continue increasing to over 180 gigawatts by 2050. This increasing capacity will result in higher generation peaks and steeper ramping. We still want green energy, and solar energy is only increasing in prevalence, so how can we deal with these effects? Batteries can store energy generated during the day and displace some of the peak loads in the evening. This is useful when overgeneration occurs, as the house can store energy for later instead of selling back to the grid. A method implemented in some regions is time-of-use rates, where electricity costs more during peak hours. These rates were trialed in Sacramento, California, and reduced peak load by roughly 8%. A different financial incentive is the removal of net metering. With net metering, utilities pay homes for all solar power they sell to the grid. Hawaii has a combination of two different systems. Smart Export allows users with solar generation and storage to sell power when solar generation is low or zero. Under Customer Grid Supply Plus, users can install solar without storage, but the utility controls the flow of the generated energy to the grid. Overall, distributed solar energy presents options to generate clean power and decrease household electricity bills. It's not quite as simple as just adding solar panels, but there are multiple possibilities to make the process work smoothly.